Okay, I think we will begin with the session. We are good to go now. So, hello everybody. A very warm welcome and good afternoon to all of you joining us from different parts of the world. All the dear authors, session chair, and guests, welcome to technical session 5C. I am Yashita and I will be your moderator for today's session. So, on behalf of Global Knowledge Research Foundation and GR Scholastic LLP, I extend a heartfelt welcome to the 10th World Conference on Information Communication Systems, Software Security and Sustainability, which is WorldS4 2026, London, UK. So, the 10th edition of this conference is being conducted in a hybrid mode. The physical conference took place yesterday in London, and we are delighted to connect with all of you virtually through Zoom on 29th and 30th July. So we have an exciting lineup ahead, and I am sure that we'll have some insightful discussions and innovative ideas. So a quick session guidelines before we start. So we will be having a total of six paper presentations today. Each presenter will be given 12 minutes for their presentations, followed by 3 minutes for question and answer session. And at the ninth minute mark, I will be giving a gentle reminder so that everyone can wrap up comfortably. And we kindly request everyone to stay connected with us until the closing remarks. Uh, and if you have any questions, technical issues, or updates to give during the session, please feel free to use the chat box. Me and my co host will be assisting you with it. So, before we begin, it is my honor to introduce the session chair for today's session. So, we have Dr. Neha Tiwari, who is working as an associate professor in the Department of Computer Science and IT at IIS deemed to be university, and she is a research supervisor with an experience of more than 16 years and also has supervised the students in a variety of projects. Her research domains include networking, machine learning, blockchain, databases, software engineering, and cloud computing as well. So, Neha ma'am, welcome to the session. Would you like to give some welcome remarks for today?
Thank you so much, Yashita, for the introduction. Looking forward for a few fruitful mutual learning session. Good luck to everyone.
Okay, thank you so much, ma'am. So, our next session chair is Dr. Juliet Meener, who is Dean of the College of Hospitality Management, Business Administration, and Computing at Pangasinan State University. She provides academic leadership in higher education and actively contributes to teaching, research, and institutional development in the fields of hospitality, business, and computing. So, I think she is not here. Wait, let me check. Okay, so she is not there. She will be joining us in a bit. So we will be starting with the presentations. So our first presenter for today is Hiruni Samarage. Are you present in the session, Hiruni? Or any of her co-authors is present on behalf of her?
Yes, I'm presenting.
Your voice is very low actually. Can you increase your voice, please?
Yeah, can you hear me now?
Yes, you are audible. So Hiruni is here with us to present her paper titled as a semantic chatbot bot framework using large language models for tertiary education. So yes, you can start your presentation, Hiruni. And a kind
Right.
request to all the
Can
presenters
I
that
have the
we are time bound, so we have to finish within the given time. So yes, I have allowed to share the screen.
right? Thank you. Yeah, hope you can see my screen.
Yes, it is visible. Just start the slideshow. Yes, it is. You can start.
Right. Okay. So good evening, everyone, and thank you so much for your for being here today. So let me tell you a story. So an year ago, I was helping a prospective student who was trying to find the right university course. So she sought my help after going through so many confusing web pages and waiting days for human replies. She said, I just wish someone could simply talk to me. That moment really stuck with me. It made me to realize how much a quick, meaningful conversation would help. So especially in education. So that's where the inspiration for this project began. So I'm Hiruni Samarage, a lecturer attached to School of Computing of the IIT Sri Lanka. And today I'm excited to present my research project, which I did for my MSc in IT, titled A Semantic Chatbot Framework Using Large Language Models for Tertiary Education. So let's dive in. So this is the outline for today's presentation. So this slide highlights the growing demand for tertiary education globally and in Sri Lanka. Worldwide, higher education enrollment continues to expand with private institutions according for a significant share. So in Sri Lanka, although more than 173,000 students, 300,000 students were eligible for tertiary education, only 42,000 entered state universities in 2024. So this gap, together with the strong post-COVID growth in private higher education enrollment, creates greater pressure on institutions to handle student inquiries efficiently. So let's begin with the familiar story. A student finishes their A-levels or O-levels, and suddenly the entire family start to find right degree. So they start asking what courses are available, how much are the fees, when is the next intake. So earlier, waiting for state universities used to be common, but after COVID-19 disruptions in Sri Lanka and unpredictable timelines, there's no longer the norm in Sri Lanka or in other countries to go for state universities. So as I found during this project, many parents now prefer private institutes if they can manage the cost to help their children to graduate early. But here's the real challenge. Usually, a marketing team of an institute receive more than 50 student inquiries daily, and sometimes more than 100 during peak periods like releasing the exam results or intake. So, and the questions from the parents come from everywhere, from the website, from social media channels, from calls, and from emails. So, this issue is the issue is the staff can't keep up. Delays can happen. Some students never hear back, and this is a competitive market. A slow response could mean losing that student to another university. So the real problem is that the institutions don't have scalable, always on system to answer them quickly and effectively. So let's look at how inquiries are currently handled at most private education institutes. It's a mix of phone calls, social media, email, and walk-ins. And while this works to an extent, it quickly falls apart during peak times. As the head of marketing at IIT Sri Lanka Institute pointed out, losing even one student's inquiry can cost over 3.5 million Sri Lankan rupees. So that's a massive hit for one message. But the truth is handling these volumes needs a large team and more staff finish working at 5 p.m. That's the exact time students and parents start reaching out. So, and converting a lead isn't quick. You have to explain the course and everything. And while doing that, more queries are piling up. So what happens? Inquiries get missed and students go elsewhere. That's the limitation of the current system. And why a scalable, always reliable solution is not just helpful, but also essential in this context. As traditional inquiry handling methods have several limitations, previous studies have explored both AI-based and computing-based solutions. So this table summarizes some of the key approaches introduced globally together with their technologies, features, sample sizes, and remaining limitations. So the aim of this project was to research, develop, design, and test and evaluate an AI-based semantic chatbot for tertiary education institutes in Sri Lanka using large language models to enhance student engagement and support. So these are the existing chatbots globally and locally with their limitations. So as you can see, mostly the existing chatbots are form type. They are asking questions regarding the student's contact details, such as the name, contact detail, contact number, and the email address. And then it will be directed to a marketing counselor. So these are some of the local examples. And these are some of the global examples from University of California and Roman University and Sunny Empires. That is the what's called Blue. So all of them are asking for student details, contact details, not the correct answers to the student's question. So after reviewing both local and global systems, a few major gaps became very clear. First one is most existing chatbots locally and globally are not fully AI powered. They follow fixed flows, collect data, but don't understand the meaning, the context, or the user intent. So students often wait hours for answers, especially after hours on weekends. Without real-time responses, personalization, or semantic understanding, institutes lost valuable leads. So this research fills that exact gap with LLM-based smart responsive support. So now that we've seen the limitations of the existing solutions, let's talk about a smarter, more scalable alternative. That is an AI-based semantic chatbot which calls the Campy derived from the campus buddy. This isn't just another form that says leave your details and we'll get back to you. This is a system that can respond to students' inquiries instantly 24/7 with accurate and helpful answers, even at 10 p.m. Or on Sundays. So this chatbot is powered by OpenAI GPT 4.0 combined with PIs for semantic search. That means it doesn't just look for keywords, it understands the question, retrieves the right information from the embedded knowledge base, and answers in a way that actually makes sense. So instead of hiring more staff or risking losing leads, universities can offer a friendly, fast, and intelligent assistance that improves the student experience and supports the marketing team. So this is the opportunity to solve a real ongoing communication challenge in higher education with scalable and smart AI. So this is the final architecture of my AI-powered semantic chatbot built using RAG-based approach. Not going to talk about this much. So basically, these are some of the layers, all the layers I have identified and generated this high-level system architecture. So let's go to the live prototype demonstration.
Okay, thank you so much, Rooney, for your presentation. So,
Yeah,
Neha ma'am, any question?
I'm still presenting.
Yeah, congratulations, Hironi, for such a nice presentation. And you put up the work very nicely, covering all the aspects and the
Yeah,
points. So I think
yeah,
you are in your postgraduate level right now.
yes. So I'm still
Okay.
presenting. Can I present my
I
project?
know that is fine. I got the idea from the architecture itself. So I just
Yeah,
want
okay.
to know about the test bed that you use.
Yeah, sure. Let me share my screen again. Um,
Just tell us the database you've taken and the size of it, also the softwares you've worked on.
yeah, sure. Let me share the screen and show that to you.
You can just name them, Hiruni. There's no need to show us the slide. It will save
Yeah,
on the time.
sure. So this is the technological stack I used. So basically, for the database, I have used SQLite, and the technology is language is Python, and AI layer has been developed by RAG with the augmented generation. Yeah. So these are the testing I have conducted. So
Where
these
you took the
tests
data
evaluated
from?
whether camp. Yeah, so I took the data from the students who are working at who are enrolled at IIT from the first year. So these are the evidences
What would be
and
the
the
size of it? Can you just tell us that?
so the final evaluation involved 22 stakeholders. More than 90% positive feedback was recorded across the main usability measures, and 95% stated that they would recommend the chatbot.
So do you think the scalability would be affected in case we increase the size?
Yeah, it will be very effective in case if we increase the size. So basically, it was tested more than 22 stakeholders, but I only got the survey uh, survey answers from the 22 stakeholders, 22
Thank
students.
you so much, Shiruna. All the best.
Um,
Yeah, thank you so much. So you can stop presenting your screen.
yeah.
So for our next presentation, we have Daula Kelvin. So are you present in the session, sir? Or any of his co-authors is present in the session on behalf of him? Let me check once. Okay, I think no one is there. So we can move forward with the next presentation. Okay, no. So next we have Tumiso Thulare. Tumiso, are you present?
Yes, I am present.
Yes. So she is here to present her paper titled as Implementing E-Participation in South African Municipalities, Lessons from the City of Bombela Pilot. So yes, you can start presenting.
Thank you, Chair. Just sharing my screen. Is my screen visible?
Yes, it is visible. You can start.
Okay, thank you. Good afternoon, everyone. My name is Tumiso Tulare, and I co-authored the paper with Kinelo Maremi, my colleague. And today we'll be presenting the paper titled Implementing E-Participation in South African Municipalities, Lessons from the City of Mbombela Pilot. The presentation outline for today will take you through the background and context. We'll also have the problem statement, the research objective, the methodology. We'll present the current state of the Mbombela city and benchmark case studies against Mbombela's readiness. And we'll present the results, recommendations, and conclusion. Public participation in the South African government system is a constitutional and legislative requirement. With that said, municipalities are mandated to engage citizens on integrated development plans, bylaws, policies, and service delivery priorities. Despite these requirements, municipalities still continue to struggle achieving meaningful and inclusive participation. At the same time, digital technologies present new opportunities for government to engage with citizens through websites, social media, mobile applications, online forums, and even digital reporting platforms. The question now is not whether municipalities should adapt to digital participation, but how do they do so effectively within their local context? Although municipalities increasingly use these digital tools, it has been found that it is used mainly for information dissemination rather than meaningful citizen engagement. Challenges such as digital divide, low digital literacy, limited institutional capacity, and governance structures continue to constrain e-participation implementation. As a result, many municipalities are still stuck at an information sharing level rather than a collaborative governance and citizen empowerment. The research objectives for this study was to assess the current state of public participation at the city of Mbombela. We also wanted to evaluate the municipality's readiness in terms of e-participation. We also identified opportunities and barriers affecting their implementation, and also generate lessons that can support other municipalities pursuing digital participation initiatives. The methodology of this research was of a qualitative design. We conducted a scoping review between for a 6-year period, 2020 to 2026, focusing on e-participation, digital governance, and local government. The scoping review was to identify and synthesize existing evidence on e-participation implementation in municipalities. It also was for us to understand key governance, institutional, technological, and socioeconomic challenges reported in the literature, as well as provide a theoretical foundation for us to assess the city of Mbombela's readiness for e-participation. To complement the scoping review, we also had segmented engagements with the officials at the city of Mbombela, departments including the public participation, communication, ICT, intergovernmental departments, policy and research representatives, and as well as the representative from cooperative governance, human and settlement and traditional affairs, also known as COGSTA. We use semantic analysis to identify recurring themes, challenges, and opportunities that emerged across both literature and municipal engagement. Ethical clearance was obtained through the CSIR Research Committee in order for us to have engagement sessions with the municipality officials. The current state of the city of Mbombela in terms of e-participation readiness revealed a mixed picture. On the positive side, the municipality demonstrates strong leadership, policy alignment, and institutional awareness regarding the importance of citizen engagement and therefore e-participation. They use digital tools such as Facebook, websites, WhatsApp, email, and even call centers. However, these tools are mainly for information sharing. They still heavily rely on on traditional ways of engaging with citizens, such as meetings, mayoral imbizos, radio programs, and physical outreach activities. Significant weaknesses remain in areas such as community digital literacy, funding, public awareness, interdepartmental coordination, and digital inclusion. This indicates that there is some form or presence of digital participation, but it remains supplementary to conventional engagement mechanism. So the overall readiness is at a moderate level. They are ready to pilot, but they require targeted support. To better understand Mbombela's position, we had to compare it with international examples. Madrid, Barcelona, and Port Alegre demonstrate mature e-participation systems where citizens' inputs directly influence planning, budgeting, and policy decisions. In contrast, Mbombela currently operates largely at an e-information stage, where digital tools are primarily used for communication rather than collaborative governance. This comparison highlights both the gap and potential pathway for future development. The results from both the scoping as well as the engagement sessions indicate that there is some implementation progress made because the city of Mbombela has existing ICT foundations. Their leadership is willing to be there and support all the initiatives that are needed to support all the activities that are needed to support the implementation of e-participation. They have also partnered with COGSTA and also some research institutions such as the CSIR. The key findings from, again, from both sessions, the sessions with the municipality and complementary of the scoping shows that digital participation in Bombela is currently at an E level, as mentioned. And then trust, institutional capacity, and digital inclusion are the most significant barriers or constraints for e-participation initiatives. For e-participation to be successful, it requires an integrated technological, institutional, and governance reform rather than an isolated digital intervention. The recommendation, therefore, from the results is that the city of Mbombela needs to update their municipal public participation strategy. This strategy will provide them with a clear direction and commitment to effective participation. They need to invest in digital infrastructure and community digital literacy programs. They also need to improve awareness and adoption of digital participation tools. This was found that there is limited awareness of what e-participation is in terms of the citizens. They also need to strengthen accountability and feedback mechanism, and also integrate e-participation into municipal planning, budgeting, and decision-making processes. In conclusion, the city of Mbombela has taken important steps towards digital participation and possess a promising foundation for future progress. E-participation is a governance challenge, not only a technology challenge. Success requires institutional capacity, citizen trust, digital inclusion, accountability, and governance responsiveness. Hybrid approaches offer a practical way, as well as when these elements are then all aligned, e-participation has significant potential to strengthen democratic local governments, improve transparency, and foster a more inclusive engagement. Thank you. Any questions?
Yes, Timish. So I hope I pronounce it correctly. I'm sorry if I haven't. All right. So the work is good. There are a few points which I would suggest you. Please keep the font size bigger so that it's legible. The size of the font was too small, especially where the real idea of your research was. So it was difficult for me. I was like zooming in and trying to read it. Most importantly, the review of literature part was missing from it. What earlier strategies, technologies, ideas were taken up, and what ignited you to, think on something different. So this was something missing in the presentation. And are you studying right now? Yeah. At what level you are? Are you working, professional?
Yes, I completed my MSc 2023 and currently working as a researcher at the CSIR.
All right, all right. So this must be a part of some big project, or right?
Yeah.
Okay, okay,
Yes.
got it.
It was part of a bigger project where CSIR had developed a blueprint of how South African municipalities need to engage in order to prepare or implement e-participations.
All right. So I think in that case, it would be a teamwork, isn't it?
Yes.
All right. So there are many people involved with you along in this
Yes.
work. All right.
Yes.
All the best. Thank you so much.
Thank you.
Right.
Thank you so much, Tamiso, for your presentation.
Thank you.
Yes. So up next we have Shola Usharani. Ma'am, are you present?
Yes, I am available. Am I audible,
Yes.
ma'am?
Yes, you're audible. So she is here to present her work titled as IoT-enabled closed-loop anesthesia delivery framework using fuzzy PID control. So yes, ma'am, you can start presenting.
My screen is visible, ma'am.
One second, it is now. Yes, now it is visible. You can start.
Yes, good afternoon to all, and thank you for giving this opportunity to present my work in this beautiful platform. And my work is on IoT-enabled closed-loop anesthesia delivery framework using fuzzy-based PID controller. And coming to the outline of my work, I will be starting with the introduction, then followed by literature survey, and what is a research gap into that literature survey, then objectives, proposed system with methodology and algorithm, and results with the references. So coming to the introduction, so basically during the surgical procedures, anesthesia administration, one of the important tasks that will be done by the physicians, and it has to be done in a high level precision so that it should not give any pressure with respect to the patient. So anesthesia administration, one of the important tasks that will be done during the surgical procedures. But this anesthesia will be done manually, that is, the physicians will decide how much to be given during the surgical procedure. Due to this, there is a possibility of the human error that may sometimes it may lead to the overdoses of drug that is given to the patient, or it may be less. Okay, so if it is overdoses, means it may lead to side effects after the surgery, or if it is underdoses, means the patient may be conscious during the surgery process. So in order to avoid those things, we have proposed a framework that is closed loop anesthesia drug delivery system, where here the patient is continuously monitored with respect to certain parameters. Based on the parameters, how much drug will be given to the patient will be decided automatically. So this will be done one of the parameter that is taken from the patient, which is called the depth of anesthesia. This will tell how much anesthesia is there inside the patient, and this will be calculated with respect to an index value. That index value is called bispectral index value. And this bispectral index value will say whether the patient is conscious or unconscious. So during the conscious state, that means when there is no surgery, if the patient is completely active, so this value will be nearly approximately to the 100. And during the surgical state, when the physician is providing the anesthesia, this value slowly will decrease, so that conscious level of the patient will reduce, and this BS value may range below the 100. And during surgical time, this value to be maintained between 14 and 60. And during the surgical procedure, we should assure that the patient should not reach the below the 20 level. So if it is reached below 20 level, it may leads to the some unavoidable situation to the patient. So these are the values it will be considered to automatically adjust the drug for the patients who are undergoing for the surgery. And this will be controlled by the system, which is called the proportional integral derivative control, which will be adjusting the how much need to be adjust to be patient to be will be given based on this PID. So all this is considered with the IoT. This the part whatever the framework that we proposed will be designed by using the IoT system. Coming to the literature survey, so we have divided the literature survey into three parts. So the first literature survey, we checked what is the how the signal is that BSA can be calculated. This BSA can be calculated based on the EEG signal. So this EEG signal having the sensor, so the sensor will calculate the EEG signal that the patient will wear this band actually. From this, bispectral index scale value will be calculated. Then followed by IoT. So with respect to the IoT, how this IoT is implemented with respect to the drug administration, we'll look into that. And along with that, we understand what should be the band that can be used for the EEG signal in order to extract the BAS value, and what kind of controllers we can use. All those things will be analyzed along with that. And coming to the last part about the closed loop anesthesia delivery system, we reviewed the so many articles which tells about what is the errors with respect to traditional drug delivery system, and what are the important errors, and how those things will be affecting the patients during the surgical and post surgery and pre surgeries all those things will be understood. And closed loop anesthesia delivery, how it will be giving the important advantage with respect to the clinical evaluation that will be understood from this literature survey. So overall, from these literature survey, we understand these are the research gaps, possibility of the human errors because of the manual drug administration, and patient feedback. That means what is the concentration of the drug level that is not taken into the consideration during the drug administration, and patient safety. We should ensure that too much level or too below level of the drug administration should not enter into the patient body. So, in order to fill these gaps, we developed the framework that will be an intelligent closed loop anesthesia delivery system that will monitor the patient brain activity of the anesthesia delivery, and based on that, automatically it will adjusting the dosage level. And that will be, in order to calculate that one, we need a bispectral index scale actually. This bispectral index scale will give the value of the drug, that value of the BAS value. Based on that, we can guess what should be the depth of anesthesia of the patient. And based on this BAS, the PID control, whatever it is given, which is used along with the fuzzy control logic, where it will set what should be the BAS value based on the anesthesia level that is there inside the patient. And this logic will tell how should be the adjust the corresponding infusion value to be given to the patient. So this is the architecture diagram we used for our framework. So we have the patient. The patient will be connected with the sensor, and this neurosense band actually it will be giving the EEG signal, and this EEG signal will be converted into the BAS value, that is bispectral index value, which will tell the anesthesia level value. And this will be given to the controller. The controller will calculate what should be the value of the BAS value and what should the value that need to be set. And based on that, how much value of the drug to be given will be adjusted and it will be given to the patient. So the methodology that is explained as from the diagram. So coming to the algorithm, so the input that to be fed to the system is the EEG from the patient, and patient demographic data will be given. The patient demographic data is nothing but patient age and weight, height details, and other information of the patient will be given. Finally, the system is going to calculate the BAS calculation and what is the infused level of the doses that to be calculated from the algorithm. So the steps will include, first it will analyze the EEG samples from the band, and that EEG samples will be computed by using the post fast Fourier transform that will calculate the various signals of the EEG signal, and those EEG signals will be converted into the BAS value, and that BAS value will be given to the fuzzy logic control system. The fuzzy logic control system will decide what is the BAS index based on that values that it is obtained from the beta ratio power, and that value will be given to the PID control. The PID control, what should be the value that is received from the fuzzy logic, what is the actual value that they are waiting in order to maintain for the surgical process will be checked, and based on that the error will be calculated. That error will be nullified by using the PID control system. And these are the various equations that we use in order to calculate the beta ratio and then PID controls, and then how much doses to be calculated. All those formulas are used over here. And finally, these are the results. So the results consist of the EEG band. The EEG band, various frequency levels is calculated of the some samples. Nearly 250 samples were taken, and those 250 samples will be converted into the beta ratio, and that beta ratio will be converted with respect to the BAS values. And finally, based on the BAS values, the PID the PID algorithm will calculate the what is the dosage level to be given over here. So this is how the given system will be implemented. It will produce the results. So these are the references that we followed. Thank you. Any questions?
Yeah, Dr. Shura.
Yes,
Um,
ma'am.
you're already a doctor, so I think is this your scholars' work that you've put up, or you're doing some different research for for your interest?
Actually, this is my PhD work, ma'am. So I just stopped with some model actually. So just extending that thing. So we are adding some more parameters inside the system actually. We are trying to checking the drug infusions by adding other parameters also.
All right. So has the degree been awarded? Because I can see doctor
Yeah,
before your
yes, ma'am.
name.
I awarded.
All
So
right.
I finished my PhD in 2020 itself.
All right. Nice. So you could have
Okay.
taken it up as a postdoc work, even, I would say. So,
Oh, okay.
yeah. So the topic is very sensitive, I would say, Dr. Shola. So
Yes, ma'am.
does it
Yes.
involve any kind of permissions or
Yeah,
some kind of?
actually, I got some hospital in our India, actually, in Tamil Nadu. We got this model is evaluated by one physician. He's a surgeon, actually, gynecologist surgeon, actually. So he evaluated the
Yeah.
model and he checked that. But the thing is, we need some more parameters. That means we have to check this environment inside the hospital, and we have just made the prototype.
Yeah, because I'm just worried for the sensitivity of the topic, I would say.
Yes, yes,
Even like we know that anesthesists are most of the highly paid
yes, yes, ma'am. Yes.
individuals from the medical domain. So
Yes,
even things go wrong at times uh,
yeah.
through them as well. So relying
So,
on system for that is like a kind of I would say people are not that very open right now at this juncture. They're not much open for this kind of work.
yeah,
So,
yeah.
what challenges you faced and how did you defend it during your Viva? This is I'm interested in knowing.
So actually, the challenge, whatever you said, is how you are going to evaluate the model actually. So actually, this one is I'm not saying completely the physician we are avoiding actually. So it will be the observation of the physician. Only thing what you are trying to make it is you are just reducing the task of the that anesthetist. So when he is giving the anesthesian the task actually, so he has to see so many things. He has to check the parameters and he has to see the patient condition and he supposed to calculate all those things manually. So instead of giving these many tasks during that time, so we are making the system is do some task automatically. So we are not completely saying that physician should be avoided and replaced actually. So we are making a system such that it should be observed by the physician. That's what the system
No,
is
no, every
including physician.
system works like that only. We don't
Yeah,
just replace things, even if like human are not involved. Even we don't replace machines or softwares just like that. It works parallelly, we would say. But anyway, like this is the topic of I would say some new interest, and it's good to see people doing this work in India. So all the best
thank you,
to
ma'am.
you.
Okay,
Yeah.
okay. Yeah,
Okay.
whatever the challenge that you are suggesting, let me. I will look into that, man. We are approaching so many hospitals, but the thing is, they are not ready to allow us to do this one actually. So we
Yes,
approached.
yes. That's what I said. They're not much
Yeah,
supportive and open for this. So
yeah,
anyway, where there is a will, there is a way. So good luck
yeah.
to you in all the endeavors. Thank you so
Yes,
much.
yes. Thank you, ma'am. Thank you for the
Thank
platform.
you, Dr.
Thank you.
Shola, for your presentation. It was a very great idea.
Yeah, thank you, ma'am. Thank you so much.
Yeah, so up next we have Norbert Annis. So Norbert, are you present in the lecture?
Yes, hello.
Yes, so he's here to present his paper titled as Learning Analytics of Arithmetic Practice Logs in the Learn with ME Intelligent Educational Software Environment. So you can start your presentation. Are you sharing your screen, Norbert?
Yes, a minute, I'm trying. Just I need hello within the settings. Is it work?
No, it is not visible.
And
Yes,
Now?
now it is visible. You can start.
Okay, thank you very
Yeah.
much. Good afternoon. My name is Norbert Anush, and in this presentation, I will focus on how automatically recorded practice logs can be transformed into meaningful learning analytics indicators. The overall goal is to show that the simple log variables can provide a useful support for teacher decision making in persons and mathematics instructions. So the motivation for this study comes from a very common problem in a digital mathematics learning, because many educational applications evaluate only the final answer. They tell us whether the student's result is correct or incorrect. This information is useful, but is also limited. This is where the log data become valuable, because these indicators, which you can see in the slide, can reveal uncertainty, miscomprehensions, trial and error behavior, or help-seeking behavior. The aim of the study was to reanalyze the CSV log files generated by the Learn with Me from a learning analytics perspective. More specifically, we wanted to transform automatically recorded interaction data into indicators that are understandable and useful for the teachers. The study was organized around the four research questions that you can see. So the focus is not only on performance but on behavior during the learning, and the key message is that the approach is transparent and teacher interpretable rather than the black box predictive analysis. Before presenting the data and the results, I would like to briefly introduce the software context. So the Learn with Me is an educational software environment designed to support arithmetic practice. Its role is not only to generate exercises and check final answers, but also to provide more diagnostic and explanatory feedback. The system records several variables that are important for the learning, include the calculation time, the difficulty level, the student answer, the student's result, the preview views, or the first try status. And these variables are pedagogically meaningful because they describe not only whether the student solved the task correctly, but also how the student interacted with the tasks. The methods and the data. This study used the secondary analysis design, so we don't collect the new data for this analysis, but we used our CSV log files, was generated by the Learn with Me between 2022 and 2024. The merged dataset originally contained more than 16,000 logged X-crisis attempts from 288 students. Each login try represent an arithmetic X-crisis attempt which included the previous maintained variables, and several pre-processing steps were required before the analyzing the data, including the harmonization and the filtering of the responses, and for the statistical tests, some variables had to convert to the binary values. The statistical analysis, when we worked it, we primarily relied on two sources from the literature for statistical tests. And for some research questions, for the first research questions, calculation time was analyzed by the answer correctness and the difficulty level. When we use Mann-Whitney test to compare the incorrect answer and the correct answer, the Kruskal-Wallis test to compare the calculation time across the six valid difficulty levels that we used, and the Spearman's run correlation to examine the relationship between the difficulty level and the calculation time. For the second and for the third research question, we used cross-tabulation analysis, chi-square test, where we used to examine the relationship about first try status, about pre-reviews, and the correctness. And the fourth research question, the student level indicators were aggregated, so the profiles were created using a rule-based median thresholds. And the results. So first main result concerns the calculation time, answer correctness, and difficulty level. The difference between correct and incorrect answers was substantial. So the correct answers had a median calculation time of 19 seconds and the mean time of 43.83 seconds. In contrast, incorrect answers had a median calculation time of 85 seconds and the mean time of 153.9 seconds. The Mann-Whitney U test confirmed that this difference was statistically significant, and this is important because it suggests that incorrect answers were not simply random errors. They were often associated with much longer interaction time, which may indicate uncertainty, lack of fluency, or difficulty in the problem-solving process. The difficulty level analysis showed a similar pattern. As you can see on the bar graph, difficulty level 1 had the highest correctness rate and the lowest median calculation time, and the other end, the difficulty level 6, had the lowest correctness rate and the highest median time. In a general, higher difficulty level were associated with the lower correctness and the longer calculation time. However, the level 6 had a relatively high number of attempts, but this does not mean that the many students were ready for this highest level, since the difficulty could be selected not only auto but self-selected, and it may also reflect challenge seeking or overestimation. For this analytics, this information is important for the teacher because the teacher can identify students who may need guidance not only in solving tasks but also to choose the best level what student need. The second result focus on the first try success. This variable is important because the final correctness alone can hide meaningful differences in learning process. When the attempt was marked as a first try, the correct answer rate was 81.43%. When it was not in first try, the correct answer rate was only 36.57%. This difference is in calculation time was also range. So the first try attempts had a median time of 19 seconds, whereas non-first attempts had a median time of 137 seconds. We did a statistical test, so the chi-square test showed a statistically significant association between the first try status and the answer correctness. And in practical terms, first try success gives additional diagnostic value. The students who solves the task correctly on the first attempt probably demonstrates more stable arithmetic knowledge than students who reaches the correct answer only after repeat attempts. The difficulty level breakdown supports this interpretation because the first try correct rate decreased from 79.66% at the difficulty level 1 to only 80.97% at the difficulty level 6. And this
Norbert,
shows,
just
yes?
a quick reminder for you that you have to wrap up within next 1 minute because it's already time.
Okay, thank you.
Yeah.
Uh, okay, the preview views, the third result concerns that the preview views function. In this study, we interpreted preview views as a long-based indicator of help-seeking behavior. The statistical tests were significant, but the effect size were too small because this means that the preview view should not be treated as a strong predictor of performance on its own. And the most meaningful from the teacher's side, the most useful teacher support perspective are the four behavioral profiles. What we indicated, so the largest group was the help-seeking learner profile. After that were the mixed profile, the supported needy learner profile, and the fast trial and error learner profiles. What we indicated. And because I have no more time, so conclude. When we bring the results together, the main message is that individual log indicators should not be interpreted in isolation. As we can solve, the time becomes more meaningful when combined the correctness, the difficulty, and the first try status. And to conclude, from a pedagogical perspective, the value of the Learn with Me logs is that they help the teachers move from final scoring toward process level interpretation, because the teacher can see not only who answered correctly, but also how student approach the task and where support may be needed. Of course, there are some limitations, so in our future work should combine log data, pre-test, post-test, or longitudinal follow-up measurements. And thank you very much for your attention. Some literature of the references, and thank you very much.
No questions from my end.
Okay, sure. So, thank you, Norbert, for presenting. So, you can stop sharing your screen.
All right. Thank you.
Yes. So, we are on the last presentation for today, and we have Sheromega and Jyoti. So, Sheromega, are you present in the session?
Yes, I am in.
Yes. So, she's here to present her paper, which is Mutated Malware Protector, obfuscated aware malware detection engine with modular detection. So, you can start presenting, Sheromega.
Wait a second.
Are you able to share the screen? Or do you need
Yeah.
any help?
Yeah, wait.
Huh.
Can you see my screen?
Yes, it is visible. You can put on the slideshow. Yes.
Okay. Good afternoon, session chair, researchers, and fellow participants. I'm Sheromika Anandajoti from Sri Lanka Institute of Information Technology. Today, I'm pleased to present our research title, Mutated Malware Protector, compiled with obfuscation-aware malware detection with modular detection. And before moving to the discussion of my framework, I want to briefly summarize a core idea. So, instead of relying on a single detection technique, our framework combines several complementary analytical layers. These include static PE analysis, anomaly detection, obfuscation scoring, behavioral approximation, modular stage inference, and explainable reporting. So, with these components, they provide consolidated threat assessment while maintaining low computational overhead. So these are the agenda contents I'm going to present to. So if we ask a question, why this problem is important as a matter? So if we compare the past to the present, the evolution of the malware has made significant changes for the past decades. So if we see the availability of our traditional signature based detection, they are well known for the detection of comparison with the hashes and byte patterns with the samples. But when we try to detect them with the modern malware that are employed with packing, encryption, polyformism, and hidden imports, they fail. And apart from that, if we see the modern adversaries, what they do is they make the detection difficult by by making the infrastructure of the malware with the dropper, loader, or the payrolls that would make the difficulty in understanding the complete attack chain. So as a result of these kind of problems, we thought of researching on a combined multi-layered framework that would give not only whether the file is malicious, but also whether it has any kind of suspicious characteristics, as well as what sort of role it has played during the attack stage. So if we see the research gap, like though there are a lot of in detection systems available in the present, like static analysis detection systems, dynamic analysis detection systems, systems that are supervised with machine learnings. They are fast and scalable, but sometimes they are not, they don't detect the heavily obfuscated PE files as they have hidden suspicious structures. And dynamic has a problem, though they are runtime efficient, but they have a problem with the infrastructure cost, delay in execution, anti analysis challenges. And if we see the supervised machine learning models, they are well known for the known and labeled malware, but for the detection. But if we compare to the new and mutated malware, they deprive from them. So, because of this gap, we address a lightweight hybrid triage pipelined with the combination of static structure, anomaly signals, obfuscation evidence, and stage role reasoning. So, if we see the solution, it has the objective, it is called mutated malware protector, and it has the major objective of identifying suspicious Windows PE malware using multiple complementary analytical layers. And there are major four contributions in these layers. The first one would be integrating multiple lightweight detection techniques, and the second one would be obfuscation aware scoring, and the third one is analyzing the role, whether it is a payload, whether it is a dropper or a loader. And finally it would provide an explainable output to support analyst decision making. And if we see the core mechanism that consists of analytical layers that contribute to different information in the final decision making, first of all, GBM static classifier, it helps on supervised classification based on engineered PE features. And if we see the second one, the isolation forest, it identifies structurally unusual binaries that may represent novel malware variants. And obfuscation score itself highlights suspicious PE features commonly associated with packed and disguised malware. And finally, behavioral risk approximation and modular inference give us a contextual information that supports analyst interpretations. And apart from that, if we see the structure, like that means the full architecture, it starts with the input of suspicious, not suspicious, the PE files, the detection of the PE files, and it scores with the three complementary indicators: the malware probability generated by the light GBM, and the anomaly score with the isolation model, and the obfuscation scores parallelly giving a static risk score. And then what happens is, then parallelly works the behavioral risk as well as the modular stage inference that gives the malicious behavior of the static and the dynamic malware, as well as the predicts whether it behaves as dropper, loader, or the payload. And then together they work as presenting the final score of the threat fusion engine, giving low, medium, as well as high threats. Beginning with 0.00 to 0.29 gives the low scorage that indicates benign behavior. The medium indicates from 0.3 to 0.69 that gives suspicious, that requires active immediate investigation. And high threat would be from would be beyond 0.7 to 1 that would need immediate attention. So this framework provides an analyst friendly output consisting of malware classification, threat score, estimated malware stage, and explainable decision to support early stage malware triage. So during the experiment setup, we had 850 samples that were expanded with through the technique of augmentation to 3,000 samples. And also we input noise injection for the real scorage to give accuracy, precision, recall, and F1 scoring, so that our model would be more precise and give a proper approximation and give the proper scoring that would that would help the presenter to make a proper decision on malware. And apart from that, the experimental results demonstrate encouraging this prototype, resulting with the 89% of accuracy, 89.28% of precision, 88.81% of recall, and 89.04% of F1 score. These balance metrics indicate that the framework is successful with the low false positive rate. And also the confusion matrix further illustrates us the majority of the benign and the malicious samples were classified correctly, supporting the effectiveness of the proposed hybrid approach. And apart from that, though we are proposing a proper idea, there are a lot of strengths and limitations as well in this model. So if we see the strengths, it has a balanced performance around 89%, and it is comprised with a multi-layered design that would give an improved robustness, and also it has an obfuscation score that would add visibility to the suspicious PE structures. And also it has modular inference support that would detect the role of the malware, whether it is a dropper, a payload, or a loader. And it also gives the users with the explainable reporting output that would give the trustworthiness
Shiromika,
within.
just a quick reminder that you'll have to wrap up within next 20 to 30 seconds because the time is already up.
Yes, sure. And limitations would be, as it is a prototype with the limited data set, and also it has the modular stage inference is heuristic and focused only on the PE Windows files. So, our future, in conclusion, our future work would be the development of sandbox telemetry with this prototype with the larger live data set that would give us more accuracy than now, and with the support of additional malware platforms incorporating the graph based behavioral analysis. Thank you. Thank you for very much for the attention, and if there are any questions you may proceed.
Neha ma'am, any questions from your side?
Yes, Shiromika. I was about to ask the challenges only, and you highlighted it in the end, but not
Yeah.
from the perspective I wanted to. Actually, when we combine multiple layers or the concepts in a framework, the only thing we have to compromise with is the latency and the response time. So I would
Yes.
like to know your idea about the same, that how will you
So
manage the latency and response time when definitely you are going to increase the size of the data as well. So it will be a very, I would say, prominent and prime challenge for this work and the framework.
So, this is a good question from the framework as we are going to develop it more and more. So, primarily, when coming to the framework, we have a lot of models, and this is a part of the component actually of the monitoring system of mine. And we have other group members, researchers as well. So, we have um, the current study focuses on primarily the detection and the accuracy. So since the latency would be managed by avoiding computationally expensive dynamic analysis models, and we would use the final decision would produced using weighted threat fusion mechanisms instead of complex deep learning models. So that's what we would
I
use.
think you need to research a bit on this perspective. So please do consider these two factors and try to implement the framework with a good data size so that you can, have the real idea of things. Thank you.
Yes. Thank you. Thank you so much.
Okay, thank you, Shiromika, for presenting. So I will give a last reminder to Daula Kelvin. Is he present or any of his co-authors is present? Okay, I think so. Then this was the last presentation for today, and we are good to conclude. So, on behalf of the Global Knowledge Research Foundation and GR Scholastic, uh, the entire team of World S4 2026 as well, I sincerely thank all our authors for their excellent presentations, valuable research contributions, and active participation. A big thank you to all the attendees for making the session interactive and engaging. Uh, this is the 10th edition of World S4, and we deeply appreciate your continued support over the years. And we look forward to welcoming you again in the 11th edition in 2027 as well. So, a few important announcements. All presenters will be receiving their digital certificates through emails within 2 working days, and the conference publication is expected to go live within 7 to 8 months. And we kindly request your cooperation with the World S4 2026 team throughout the publication process. So I would like to express my sincere gratitude to our session chair. So thank you so much, Neha ma'am, for joining us. And unfortunately, Dr. Juliet was not able to be the session chair for today. So this is a small token of appreciation on behalf of GR Foundation and GR Scholastic LLP. So once again, thank you everyone. And before we conclude, there's a last request that please switch on your cameras for a quick snapshot of the conference, please.
Thank you so much, Yashita. I'm privileged to be a part of this session. And congratulations to your entire team for completing a decade in this at this international level and for this conference series. So all the best to all the participants. Thank you so much.
Yeah, thank you, Neha ma'am, for those words. So I will quickly take a snapshot. 1 second. Yes, thank you once again. Stay safe and have a wonderful day ahead, everybody. Thank you.
Thanks.
Goodbye.
Bye.
Bye.
Thank you.